Alright, welcome as we continue with our mathematics meal. Remember, there is need for you to subscribe to our YouTube channel, Mathematics Meal 1, and then you can also follow us on Facebook so that you can continue to enjoy different meals from Mathematics Meal. We'll give you breakfast question, lunch question, and even dinner question. We are still on Maths 102, and we are still on Coordinate Geometry 1. We have looked at the basics, the foundation to Coordinate Geometry 1, and we want to move to another part of Coordinate Geometry 1. And in this video, we are going to consider distance between 2 points on a straight line. As you continue to watch this video, make sure that you subscribe to our YouTube channel and also leave a comment for us in case there is an aspect you want us to improve in our videos. Alright, let's begin this journey immediately. Now, if we have a straight line, if I have a straight line, we know what a straight line is. A straight line is the shortest distance between 2 points. If I have this point and I have this point, this is a straight line. The shortest distance between 2 points is a straight line. So someone may decide to move from you this A and this B. Someone may decide to move like this. That's the person's business, you know. There are people that they don't like shortcuts. They don't like shortcuts. In some cases, shortcuts usually cut life short. But as far as straight line is concerned, that's the shortest distance. This one will not cut your life short. So if we have a straight line and we have points on a straight line, we can actually find the distance between 2 points on a straight line. Let's say I have P and Q. I can do that. I can find the distance between these 2 points. So what will enable us find that distance is actually coordinate geometry. That's what we want to consider in this video. So consider the figure or the diagram below. The figure below. Let's look at this. If I have this is a plane. How that? That's my x. That's my y. If I have a straight line here, and I have point P and point Q, these 2 points are on this straight line, and I want to find the distance between P and Q. Don't ask me what I'm doing with the distance. You don't know whether I want to go to the house of P from Q. So don't ask me what I'm doing with the distance. Just know how to find the distance. So we want to find the distance between P and Q on this straight line. Now, for us to locate P, Q here, we have coordinates. Q is at a certain value of x, which I may refer to as x1, and then also at a certain value of y, which I may call y1. So here at Q we have ordered pair. The same thing applicable here. Now P is at a certain value of y also, which I may call y2, and then this s2. You know, when you are drawing your graph, you just move this where they intersect. That's your point. So we have this. So we have ordered pair here, x2, y2. When x is 2, y is 2, that's how we arrive at this. The same thing here, we have x1, y1 for Q. Now I can join this. So I form a right angle triangle here. Let's say at point R. Alright, you remember that in a right angle triangle, it's a beautiful triangle. It's a beautiful triangle that we have a theory we call the Pythagoras theory. And Pythagoras theorem states that in a right angle triangle, the square of the hypotenuse is equal to the sum of the square of the other 2 sides, provided the triangle is actually a right angle triangle. So if I say let this distance PQ, let PQ, that's this line PQ, or let's say side PQ. In geometry, that's the symbol for side D. So let here be D. Now applying Pythagoras, you discover that PQ is actually the what? The hypotenuse. Why these are the other two sides. So if I apply Pythagoras theory, so applying Pythagoras theory, we can have that PQ squared is equal to the sum of the other two sides. So it's equal to QR squared plus what? PR squared. Okay? So PQ squared is equal to PQR squared plus what? PR squared. Now we have said let's PQ, which is the distance between the 2 points where the interest we have, that's what we're interested in, D. So it means that D squared is equal to, what is QR? QR. If I want to find this distance, I will use this to subtract this. So QR will actually be x2 minus x1. Because it's squared, we are going to square it, plus PR is from here to here. To get from here to here, which is from here to here, I will use y2 to subtract y1. So I'm going to have y2 minus y1 all squared. Alright, so if I want to find this distance now, D will become, let's find square root of both sides in order to get my D. So I'll have x2 minus x1 squared plus y2 minus y1 all squared. So to find the distance between 2 points on a straight line, I use that equation there, where D now is the distance between 2 points on a straight line. So when the coordinates of the 2 points are known, like if I know this coordinate and I know this coordinate, then the distance between them can be what? Can be found. Yes, can be found. So once the coordinates of 2 points are known, then the distance between them on the straight line joining them can be what? Can be found using that expression. All we need to do is to identify the coordinates, yes, and then substitute in this expression or in this equation, and then we can be able to get our distance. It's still possible that we can be given distance and one of the coordinates will be taken away, and then we'll be required to actually calculate one of the coordinates, as either the x coordinates or the y coordinates. Alright, we're going to take one question and then we'll go for a break. But when we return, we'll now focus our attention on solving variety of problems as far as distance between 2 points on a straight line is concerned. So let's quickly take a question. I believe that you are enjoying the class. Yeah, it's very, very important that you enjoy this class. Very, very important. Mathematics is usually sweet, so that's why we are trying to touch your life with mathematical hand so that you will be mathematically transformed. That's our business. Let's take one question for now. Example 1. Let's say we have example 1. So let's say find the distance between the line between these points. These points, what are the points? Point A consisting of 1 and 3, and point B consisting of 5 and 6. Let's say we have this and we want to find the distance between them. Okay? So let's move. Alright. Now the first thing, let's put down the coordinates. We have 1 and 3, and then we have B, point B, 5 and 6. Okay? Now all we need to do is to identify the coordinates x1 and x2, then y1 and y2. Now here, if we are taking here as our point 1 and point 2, that's point 1, point 2, here we're going to have x1 to be 1 and y1 to be 3. Then it means that here we're going to have s2 to be 5 and y2 to be 6. So having identified our x1 and y and y1, then s2 and y2, then we can comfortably begin the journey. D is equal to square root of x2 minus x1 all squared plus y2 minus y1 all squared. So we now substitute. Let's substitute and move on. Let's substitute. If we substitute, what will be d? D will be equal to square root. D will be square root of, what is s2? S2 is 5. 5 minus 1, that's s1 all squared, plus, what is y2? 6 minus y1 is 3 all squared. That will give us square root. 5 minus this will give me 4 raised to the power 2. 6 minus this is 3. 3 raised to the power 2. That will give me square root of 4 squared is 16. 3 squared is 9. That is square root of 25. And finally we have what? We have 5. That's beautiful. Very beautiful and simple. Now, all you need to do is just to substitute and you'll be able to arrive at your answer. Now, one other important statement I have to make. You know, I just chose A to be my first point and this second point. That's why they have the subscript too. It's still possible I can say, let this point be my first point and this be my second point. So this one will now have the subscript of 1, 1. Then this one will now have 2, 2. No matter the one you choose as your first point, you arrive at the same answer, because when you now choose this as your first point, now you subtract. Even if you have a negative value, when you say 1 minus 5, you are going to have minus 4. And when you square minus 4, it will still be positive 16. So you see, the choice of your point is not necessarily of great importance. You can decide that this one will be your first point, while this become your second point, or this one become your second point, while this become your first point. But it's usually okay to use the first point given in the equation just as your first point, while the second point given in the equation as the second point. One thing is important, you see, is x1. Where we have s1 is where we are going to have y1. Where we have s2 is where we are going to have y2. Some people may just look at it, they may pick x1 here and go here and say that here will be y1. No, s1 and y1 will be together. The same thing, s2 and y2. So if I decide to call this x1, that means definitely this becomes what? y1. And if I decide to call this s2, definitely this becomes what? y2. Alright, that's all for now. But we're going to come back to solve series of questions as far as distance between 2 points on a straight line is concerned. Thank you and God bless you. Remember, subscribe to this channel and make sure that you leave a comment in case there is something you want us to do as far as these videos are concerned. I love you.